rectangular cross-section bar is welded to support by means of fillet weld whose side view is shown in the figure. Find the throat area of rectangular fillet weld of size of weld is 10 mm. Here is the side view of the weld. Here the length of the weld is 120 mm and width of the weld is 80 mm. And here the options are 9600 mm square. So it is 96,000 mm square, 28 mm square. Here 38,400 mm square, and here the option D is 5,656 mm square. So coming to the throat area of rectangular fillet weld is given by the thickness of the weld into 2b plus 2l. But here the thickness of the weld is equal to 0.707 times the size of the weld, where size of the weld is given by 10 mm and length is equal to 120 and B is equal to 80 mm. So here the total throat area of the weld is equal to 0.707 into 10 into 2 into 80 plus 2 into 120 and is equal to 2828 mm square. So here the right answer is 2828 mm square, and in the option the correct option is B. B is the right answer. Regular cross section bar is welded to support by means of fillet weld whose side view is shown in the figure. Find the throat area of rectangular fillet weld of size of weld is 10 mm. So here the given diagram, so of a welded joint, here length is 80 mm and width is 120 mm. So coming to the area of throat weld is equal to T into 2b plus 2l, where T is the thickness of the weld which is equal to 0.707 times size of the weld and is equal to 2b plus 2l. So already we know the all the values width and length. So from this equation we get the area of the fillet weld is 2828 mm square, 2828 mm square in the options. The correct option is B. B is the right answer. Flywheel rim is 3787 kg and density of flywheel rim is 7200 kg per meter cube. If radius of flywheel is 1 meter, the cross sectional area of the flywheel rim will be. Here the options are 84 meter square, 8.4 meter square, 0.84 and 0.084. Coming to the solution, from the relation mass of the flywheel that is equal to 2 pi r into A into rho. Here 2 pi r A gives the volume of the flywheel and rho gives the density of the flywheel, which gives from this relation the cross sectional area of the rim is equal to m by 2 pi r into rho. And all the values are known values. Here mass of the flywheel is 3787 and density of the flywheel is 7200 kg per meter cube and radius of the flywheel is 1 meter. So which is equal to, which gives a value of 0.084 meter square. So in the option the correct option is D. D is the right answer. Heated static tube is used to measure the velocity of water in a pipe. The dynamic pressure head is 40% of the stagnation pressure head. The static pressure head is 60 centimeters. What is the velocity of flow? Assume the coefficient of the tube is equal to 0.98. Here, while using the static pipe tube, the velocity of the flow is given by root 2gh, where h is the dynamic head. So, but we know that the stagnation head is equal to static head plus dynamic head. So already we know that the static head is equal to 60 centimeters, that is 0.6 meters, and dynamic head is 0.4 times the stagnation head. So from this equation the stagnation head is equal to 1 meter and dynamic head is equal to 0.4 meters. So the velocity of the flow is equal to root of 2 into 9.81 into 0.4, where it is equal to 2.74 meter per second. So in the option the right option is A. A is the right answer. Prandtl number for a certain gas is 0.8. The relation between velocity boundary layer and thermal boundary layer thickness is given by. Here are the options. Del is velocity boundary layer thickness and del suffix T is thermal boundary layer thickness. And here are the relation between these two. Del is equal to 3 delta T. Delta is equal to 0.928 delta T. Delta is equal to 1.077 delta T. And delta is equal to delta T. Here the relation between the thermal boundary layer thickness and the velocity boundary layer thickness is given by del by del T is equal Prandtl number power of 1 by 3. So here we know the Prandtl number of the gas, that is 0.8. So from this relation we get delta is equal to 0.928 delta T. So here the right answer is 0.928 delta T. Sorry, it is 0.928 delta T, and in the options the correct option is B. B is the right answer. Entropy increased per kg of water when it is heated from 0 to 100 degrees centigrade will be, take Cp of water is equal to 4.18 kilojoule per kg Kelvin, and here the options are 0.5 kilojoule per kg Kelvin, 1.3, 1.9 and 1.3. Sorry, it is 13 kilojoule per kg Kelvin. So coming to the solution, the change in entropy in a heating process is equal to Cp ln T2 by T1, where T2 is the final temperature and T1 is the initial temperature. Here the final temperature is 100 degrees centigrade and initial temperature is 0. So and Cp is given as 4.18 and it is equal to 100 degrees centigrade, just convert into in Kelvin, that is 373 by 273. So which is equal to a value of 1.3 kilojoule per kg Kelvin, and in the options the correct option is B. B is the right answer. In an air standard cycle, the compression ratio is 16. At the beginning of isentropic compression, the temperature is 15 degrees centigrade and the pressure is zero point 0.1 megapascal. The temperature at the end of the compression process is, here the options are 500 degrees centigrade, 873 degrees centigrade, 600 degrees centigrade and 773 degrees centigrade. Coming to the solution, in an isentropic compression process, the ratio of final temperature to initial temperature is given by the ratio of final pressure to initial pressure power of gamma minus 1 by gamma, or Rp power of gamma minus 1 by gamma. Or we, we have another equation, that is T2 by T1 is also equal to V2 by V1 whole power of gamma minus 1 by gamma. Sorry, it is gamma V1 by V2 whole power of gamma minus 1. That is the compression ratio. V1 by V2 gives the compression ratio, that is R power of gamma minus 1. And here the compression ratio is equal to 16 power of gamma minus 1, that is 1.4 minus 1. Because in an isentropic compression gamma is equal to 1.4, this is an adiabatic index, and T2 is equal to 16 power of 0.4 into T1 is 15 degrees centigrade, that is 288 Kelvin, which is equal to a value of 873 Kelvin or 600 degrees centigrade. So the right answer is 600 degrees centigrade, and in the option the correct option is C. C the right option. The thermodynamic system undergoes a cyclic process in which heat transfers are 14.7 kilojoules minus 25.2 kilojoules minus 3.56 kilojoules and 31.5 kilojoules. The net work for the system is, here the options are 17.44, 5.34, 21.734 and 3.5 kilojoules. Here there are four heat transfers in a cyclic process. So here positive sign indicates heat supplied to the system and negative sign indicates heat rejected from the system. Here in a cyclic process, the equation is given by cyclic integral of dq is equal to cyclic integral of dw. So here cyclic integral dw gives the net work done for the system, so which is equal to cyclic integral of dq, that is the net work done for the system is equal to 14.7 minus 25.2 minus 3.56 plus 31.5, which is equal to 17.44 kilojoule. So here the right answer is 17.44, and in the option the correct option is A. A is the right answer.